Hello friends, I Deepak Prajapati welcome you in lecture number 11 on random variables. In previous lecture we have defined cumulative distribution function of a continuous random variable, and we have explained one example that how to find out cumulative distribution function from a given probability density function. So in that example we have used the definition of distribution function of a continuous random variable. So we have used this definition: value of CDF at any point A is given by integral of PDF from minus infinity to A, and this is defined for every real number A. So using this definition we have done one example in previous lecture, and we have shown that how to find out distribution function from a given probability density function. So today we are going to discuss another method which is different from this method for the same example which we have discussed in lecture number 10 on random variables. So the idea of another method is, we know that this definite integral from minus infinity to A represents the area under the curve of probability density function known as density curve up to this point x equal to A. So this integral is nothing but area under the density curve up to x equal to A. So if we are able to find out the area without integral, then we don't have to go for integral. Using some geometrical formulas for area, we can decide the area under the density curve. But this method is applicable only if our function is linear function. So here function is 1 by 8 plus 3x by 8 in between 0 and 2, otherwise it is 0. So function is linear function, so we can use this another method to find out cumulative distribution function for given probability density function. Okay, so this is the same problem which we have done in lecture number 10, and here we are going to do this same problem using another method. So suppose the PDF is given by fx equal to 1 by 8 plus 3x by 8 if x lies between 0 and 2, otherwise it is 0. So we have to find out the distribution function of random variable capital X whose PDF is given by fx. So as we have discussed in the last lecture, our given PDF is non-zero in between 0 and 2, and outside this interval the value of PDF is 0. Now in between 0 and 2 function is given by straight line, so we can easily sketch this graph of fx between 0 and 2. Okay, so if we put x equal to 0, then we will obtain 1 by 8. So the point corresponding to x equal to 0 is 1 by 8. So it is 0, 1 by 8. And the point corresponding to x equal to 2, if we put x equal to 2 here, we will obtain 1 by 8 plus 6 by 8, that is 7 by 8. So these are the 2 points on this line. So joining these 2 points we can find out the graph of PDF between 0 and 2, and the graph of PDF outside this interval is 0. So this is the graph of PDF between 0 and 2. Between 0 and 2 it is given by this 1 by 8 plus 3x by 8. So up to this point, up to x equal to 2, and starting from x equal to 0, this is the graph of PDF between 0 and 2. And if x is less than 0, it is 0, and if x is greater than 2, it is 0. So the graph is on x-axis if x is greater than 2 and x is negative, that is less than 0. So we can use this formula of area. Okay, we know that f of a is nothing but area under the density curve. We know that f of a is given by minus infinity to a fx dx. So this integral represents the area under the curve of PDF up to x equal to a. So using that concept, if we are able to find out area without doing integral, then also we can do the same problem without doing integral. So here we will consider again three cases. If x is in this part, then it is negative. If x is lying in this interval between 0 and 2, and if x is here, and instead of x we will use another variable small a. So if a is negative, if a is in between 0 and 2, and if a is greater than 2. So we consider three cases one by one. Suppose a is negative. So if a is negative, then we know that if a is negative, then we are to the left side of 0, and if x is negative, then value of PDF is 0. Okay, so if a is negative, we can directly write f of a equal to 0. Now second part is if a lies between 0 and 2. So if a lies between 0 and 2, then suppose a is somewhere here, then this is going to be, in this we can write as minus infinity to 0 plus 0 to a, but in minus infinity to 0 function is 0, so this is 0 to a fx dx, because in minus infinity to 0 probability density function is 0. Now this is nothing but area under the curve fx between 0 and a. So this shaded area is the area under this curve. Now we are not putting value of fx, and we are not going for integral, that we have done in previous lecture. What we will do is we will try to find out value of this area using geometry. Okay, so if I want to find out value of CDF at point A, where a lies between 0 and 2, this a is any real number between 0 and 2, then f of a means this shaded area. We have to consider area to the left of a. So f of a is nothing but this shaded area. Now you can see this shaded area is nothing but summation of two areas. First we can consider this rectangle OACD. So it is summation of area of rectangle plus area of this triangle ACB. So here I have written, if a is in between 0 and 2, f of a is nothing but area of OACD. OACD means area of this rectangle plus area of triangle ACB. So this is the triangle ACB. So now area of this rectangle is length into breadth. So we have to multiply this O into D into C into D. Now value of O into D is A, and value of this portion CD. This length is 1 by 8 and this length is A. So it is A by 8. So area of this rectangle is nothing but multiplication of two sides. So this side has length of OD is A, and length of CD is 1 by 8. So it is 1 by 8 into A, using the formula for area of rectangle, into area of triangle ACB. So area of triangle ACB is 1 by 2 into base into height. Now base is nothing but this AC. AC is the base of triangle. So it is 1 by 2 into AC into BC. Or we can write CA into BC. This is A by 8, 1 by 2. Now what is the length of AC? So length of AC is small a. We have to go up to this. So this is at this point A and up to C. So AC is A minus 0, that is A. And BC is, so if you consider this one BC, then BC is nothing but BD minus this whole length BD minus we have to subtract this length CD. So BC is nothing but BD minus CD. Now what is BD? So BD is the value of function at x equal to a. This whole part BD is nothing but value of function PDF at x equal to a. So we write f of a. BD can be written as f of a. And value of CD is 1 by 8. So we put CD equal to 1 by 8. And if we simplify, now f of a can be calculated by putting x equal to a in this formula. So it is 1 by 8 plus 3a by 8. Okay, value of this function at x equal to a. So we have to replace small x by a. So f of a is 1 by 8 plus 3a by 8 and CD is 1 by 8. So you can see 1 by 8 will cancel out and we are left with 3a by 8 into a by 2. So this is after simplification a by 8 plus 3a square by 16. So this we obtain without using integral. Okay, we are just using the formula for area of rectangle and area of triangle. So this is value of CDF at x equal to a if a lies between 0 and 2. Now if a is greater than 2 means if we are on this side, if a is greater than 2 means a is somewhere here, then we have to consider if a is greater than 2, then what is f of a? So f of a is by definition probability that x is less than or equal to a. Now a is greater than 2 means suppose a is somewhere here. So we have to consider probabilities up to 2 and then probabilities from 2 to a. So probabilities up to 2 is nothing but capital F of 2 and in 2 to a fx is 0. So this I can rewrite as capital X less than or equal to a. Okay, we have this type of situation. Suppose this is 2, this is a. So capital X less than or equal to a is nothing but union of two events, capital X less than or equal to 2 plus this part 2 less than x less than a, and this is capital F of 2. And if we consider this part, then in this part if a is greater than 2, value of PDF is 0. So probability is 0 for this event if x is greater than 2. And f of 2 can be obtained by this putting a equal to 2. So if we put a equal to 2, it is 2 by 8 plus 3 into 4 by 16, that is 12 by 16. And after simplification we obtain 1. So if a is greater than 2, f of a is 1. And if a is in between 0 and 2, f of a is given by this. And if a is negative, f of a is 0. So we can combine all the possibilities and we can write this CDF in this way. For a negative it is 0, if a lies in close interval 0 to f of a is a by 8 plus 3a square by 16, and if a is greater than 2, f of a is 1. These two we can directly write down. If a is negative, we can directly write down it is 0, and if a is greater than 2, it can be written as 1. So if our function PDF function is linear, then we can determine the value of CDF without doing this integral. Using geometry, we can find out the area under the density curve, but this is applicable only if our function is linear. Now suppose our CDF is non-linear like this, then we cannot use this method, because we don't know direct formula for this type of areas. So be careful to use this method. You have to take care whether probability density function is a linear function or not. So we consider another example in which probability density function is non-linear. So suppose the probability density function of a random variable x is given by fx equal to x square by 8 if x lies in 0 to 2, and fx equal to x into 4 minus x by 8 if x lies between 2 and 4, and outside these two intervals function is 0. So we have, suppose this is 0, 2 and 4. So function is different in 0 to 2, it is different in 2 to 4, and outside this interval it is 0. So in 0 to 2 fx is parabola, in 2 to 4 also fx is parabola. And to find out CDF, we will use this formula. F of a is integral from minus infinity to a fx dx for every real number a. So first we consider if a is negative, means outside this interval. So if a is negative, f of a is minus infinity to a fx dx. Now here x is running from minus infinity to a, that means x is less than or equal to a, and a is negative, so this implies x is also negative, and if x is negative, value of PDF is 0. Okay, so integral is 0. So CDF at x equal to a is 0 for every a negative. If a is negative, f of a equal to 0. Now suppose our number a is in close interval 0 to 2, then in this case we understand from this figure, this is the figure of density curve for this probability density function. So this a is in between 0 and 2, so we assume that suppose a is somewhere here, it is in between 0 and 2. This is 0. So if a is in close interval 0 to 2, then area to the left of a is this shaded area, shaded by blue lines. So this shaded area represents the area to the left of a, that is nothing but value of CDF at x equal to a. Now to find out capital F of a, we can consider f of a equal to minus infinity to a fx dx, but up to 0 value of function is 0, and in between 0 and a value of function is non-zero. So we will break the interval into two parts. F of a is going to be minus infinity to 0, not minus infinity to 0, minus infinity to a integral of PDF. Now a is here, so we have to consider from minus infinity to a. Now up to 0 value of PDF is 0, So we have to break this interval into two parts, minus infinity to 0 plus 0 to a f dx. Now here value of function is 0, so we are left with 0 to a f dx, and so we have written in this way: if a is in between 0 and 2, f of a is minus infinity to a fx dx. This is, as I explained, minus infinity to 0 plus 0 to a fx dx. Now in minus infinity to 0, fx is 0. Now if x is in between 0 and a, if x is in between 0 and a, then because a is less than or equal to 2, x is also in interval 0 to 2. Okay, because x is less than or equal to a and a is less than or equal to 2, therefore x is also in this interval. And if x is in this interval, value of CDF is given by, value of PDF is given by x square by 8. So we put x square by 8 here. Okay, here we can put x square by 8 because a is less than or equal to 2, therefore x is also less than or equal to 2. So f of x is x square by 8, and this is simple integration. Integral of x square by 8 is x cube by 3, and 3 into 8 is going to be 24. Limit is from 0 to a. So after putting limit, we obtain f of a equal to cube of a divided by 24 if a lies between 0 and 2. Now suppose a lies between 2 and 4. So that I have explained in this figure. Suppose small a is somewhere here between 2 and 4. Now f of a is, we have to consider integral up to this point, minus infinity to a. But now we consider minus infinity to a into two parts. We consider integral up to 2 and then from 2 to a. So this I can rewrite as minus infinity to a is breaked into two parts. Minus infinity to 2 means up to this area, area to the left of 2, plus 2 to a. Okay, so it is not necessary to sketch the figure. This is just for understanding. Otherwise it is simple, you can directly write this also. Minus infinity to a fx dx is, because a is between 2 and 4, we have to take care if we are having less than or equal to 2. So minus infinity to 2 and then 2 to a. Now this is nothing but value of CDF at x equal to 2. This area shaded by red lines is nothing but value of CDF at x equal to 2. Area to the left of 2 is capital F of 2, and this area to the right of 2 is nothing but integral of PDF between 2 to a. Okay, this area is nothing but this one, and f of 2 is given by this. So area up to small a is nothing but summation of these two areas. So area to the left of 2 is f of 2, and area to the right of 2 and left of a is nothing but integral of PDF from 2 to a. Now here a is less than or equal to 4, so therefore here we have 2 less than or equal to x less than or equal to a. For this integral, limit of integral is x equal to 2 to x equal to a, but a is less than or equal to 4, therefore x is also in the interval 2 to 4. So if x is between 2 and 4, we have to put fx equal to, if x is between 2 and 4, fx is x into 4 minus x by 8. So in that part, because x is between 2 and 4, we will put fx equal to x into x minus 4 by 8. Now what is f of 2? So f of 2 we will obtain from this. We have obtained that f of a is a cube by 24 if a lies between 0 and 2. So we can find out f of 2 by taking a equal to 2 here. So that is going to be 8 by 24. So it is 8 by 24, and here we put value of fx. If x is between 2 and 4, fx is x into 4 minus x divided by 8. This we can rewrite as 1 by 8 can be taken outside. This is 4x minus x square dx. This is 1 by 3 plus 1 by 8. Integral is 2x square minus x cube by 3. Limits of x are from 2 to a. So first we put x equal to a, then x equal to 2, and if we simplify this, we will obtain f of a equal to 6a square minus a cube minus 8 divided by 24 if a lies between 2 and 4. Now last case is if a is greater than 4. So that also we can understand in this way. Graph is something like this. This is 4, here it is 2, and a is somewhere here. A is greater than 4. So f of a is minus infinity to a fx dx, and now I know area up to this, okay, because at a equal to 4 I can find out f of 4. So area up to this a is nothing but area up to 4 plus 4 to a. So area up to 4 is given by minus infinity to 4 fx dx. Okay, this is minus infinity to 4 fx dx plus 4 to a fx dx. Now this is nothing but f of 4. Minus infinity to 4 fx dx is nothing but f of 4 by the definition of CDF. And here x is greater than 4. Here integral is from x equal to 4 to a. So x is greater than 4. And if x is greater than 4, PDF is having value 0. Okay, it is the definition of PDF is if x is outside 0 to 2 and 2 to 4, fx is 0. So if x is greater than 4, fx is 0. So we can put fx equal to 0 for x greater than 4. So this part is going to be 0. Okay, so it is f of 4 plus integral of 0, that is 0. And f of 4 we can obtain from this. Here we put a equal to 4. So it is 6 into 4 square minus 4 cube minus 8 divided by 24. And if you simplify this, you will obtain 1. So f of a is 1 if a is greater than 4. So if we combine all these cases, then cumulative distribution function of a given random variable x is given by this formula. If a is negative, f of a is 0. If a is between 0 and 2, f of a is a cube by 24. If a is between 2 and 4, f of a is 6a square minus a cube minus 8 divided by 24. And if a is greater than 4, f of a is 1. Here a is dummy variable. Instead of small a, you can write small x also. So in this way, if our function is non-linear, then we can use definition of CDF. We are just using this definition. F of a is nothing but integral of PDF from minus infinity to a fx dx. So if our function is non-linear, then using this definition we can find out the cumulative distribution function of a continuous random variable. If function is linear, then we may use the formula of triangle of known objects, formula of area of known objects to find out the CDF. So that is your choice. You can use the method which is comfortable to you. But if function is non-linear, like this example, fx is given by parabola. Okay, here function is non-linear, then you have to go by definition using definite integral. So in this way we can decide the distribution function of a continuous random variable whose probability density function is given. So I hope you like this lecture. In the next lecture also we are going to discuss some more problems on cumulative distribution function of a continuous random variable capital X. Thank you very much.